All right, one more time before we review or we go on, we want to review a little bit about perpendicular lines. A couple things that I didn't mention in the last one that it might be something to think about and know about when it comes to this kind of stuff, that it's important to understand that when we go up here and we draw a line straight through from A to D, and we notice, and I draw an arc here, okay, and we draw these two, and we know that these are there. We know that together, again, these are going to equal 180 degrees. So that means that this is a linear pair, this is a straight angle, and that these two angles are supplementary to each other. And the same thing would mirror on this side, and we could go all around. We can sit there and go that these two angles are also the same, and so forth all the way around. Okay, so it's a key thing, and to emphasize that it's so important to know that you can identify that stuff to help you out to find out what is a straight angle. It gives you the 90-degree scenario and all that stuff too when we get to doing more complex problems like the one we're going to see next in this example right here. Okay, so in this one right here, we have find x and y so that PR and SQ are perpendicular. Okay, so we got to look in here. I'm going to draw little red symbols in here if we want to make sure we look at all this stuff. I'm going to say that we're going to put a little symbol right there in the corner to make sure that it's 90 degrees. Okay, and that means we also could sit there and say, okay, that one's going to be 90 degrees. Okay, this one's going to be 90 degrees, and then this one, these two together are going to equal 90 degrees as well. So that makes it a little bit easier to understand. So what we want to do is, because we know right up here that this angle right here already has a symbol in that it's 90 degrees, we're going to take this and we're going to go 90 degrees equals 4y minus 2. Okay? Therefore, we can sit there and start moving things around algebraically by adding 2. Both sides giving me 92 equals 4y. And then we can divide both sides by 4. Okay, we get our handy dandy calculator. Turn it on. Clear out. We go 92. Remember, it's 92, not 90. Divided by 4 gives me an answer of y equals 23. So there's our first answer. Now, solving for x is going to be a little bit more complicated, but not much. As we mentioned before, okay, let's do this with here. We mentioned, as we marked our thing, that we know that these two angles together are going to equal 90 degrees. Like we said up here, this was going to be 90 degrees. So what we have to do is set these two up. We're going to write it as 2x plus the second angle, which is 5x plus 6, and we're going to equal this whole thing to 90 degrees. Now we're going to combine like terms. Okay, these two combined together gives me a 7x plus 6 equals 90 degrees. Okay, then we go ahead and get rid of the 6 by getting it to the other side. Gives me 7x equals 84, and then we divide both sides by 7, and that means x is now going to equal, get our calculator out, clear out, we want to go 84 divided by 7 equals 12. Okay, so we have 12 here, and that's our answer to that one. So I want you guys to do the same thing down here on the next example on your own, and then we can talk about it in class later if you choose to. Okay? All right. Let's turn to the next page and see what we got here. We're down to our last page of notes for section 1.5. Okay? Here we go. It says, interpreting diagrams can be assumed and cannot be assumed. Okay? So what do we got here? So, what can be assumed? We can assume that, as we notice, that this is in a plane, so we can assume, I'm going to move here so I can do this a little bit better, is that all points are coplanar. Okay. Oops, I spelled that wrong with an A. Okay, so coplanar, that means all these points lie in the same plane. Okay. We can also say that G, H, and J, so we have these ones right here, are co-linear. And remember the definition of that, we can sit there and say that because they lie on the same line, and there's at least 3 of them, that they are considered to be collinear. Okay, we also can sit there and say that HM, HL, and notice what symbol I'm putting over the top of each one of these. HK and G, J are all rays, okay, and they all intersect at H, okay. We can also assume that H is between G and J, okay. We can also say that point L is in the interior of angle MHK. So I apologize for writing over the top of that. My handwriting's so big. We can also say that angle GHM and angle MHL are adjacent. Okay. We can also say that angle GHL and angle LHJ are a linear pair. And again, why can we say it's a linear pair? Because they are adjacent and they equal 180 degrees. And the last thing we can sit there and say that angle JHK and angle KHG are supplementary. Whew. So there's lots of things in here that we can talk about. Okay? Lots of things that we deal with that are there. Now, what can we not assume? Okay, interesting thing here. We cannot assume, okay, and with all the stuff that we've learned so far is, I'm going to move this over just a little bit, is that, well, we just learned that HM and HL cannot be perpendicular. We don't know that. It kind of looks like it, but we know we can't assume it. Some people like to assume it, even though the picture might look it, but we cannot assume that. So this is a big no on this. Okay, we can't assume that. Okay, another thing we can't assume, and sometimes because we don't have the symbolisms in there, is that angle JHK is congruent to angle GHM. Okay, so we have JHK and GHM. It kind of looks like they might be vertical angles, and we could possibly think about that, but we have no markings in here to indicate that they are congruent to each other in any way or form, okay? So other ones we can't assume that are going to be that way are also angles. Okay, this is all these are no's. Okay, angle JHK cannot be equal to angle KHL. Okay, or angle KHL. That's supposed to be an H up there. cannot be, because again, LHM, these are all no's, because why? Because there are no markings. So now if we go down here, see how there's markings in here like this? That tells us that things are possibly congruent. But if there's no markings on there, we can't assume anything. They said that there's a saying that some people cannot do stuff for them, assume things that gets them in trouble every single time. Same thing with segments, okay? These are our angles, okay? And then down here we want to talk about segments. And we can't assume that GH is congruent to HJ. Again, we cannot, because there are no markings that tell us that these things. We can't say that HJ is congruent to HK, or HK is congruent to HL. And the last one, we can't say that HL is congruent to HG. Again, we can't assume, because there's the key word, assume, okay, that these are true, because we have no markings like we show in this one down here. See, you have these markings here, indicate that they are going to be congruent to each other. Again, this marking right here says that these two angles are congruent to each other. This marking here indicates that that is 90 degrees. So any symbolism that we have until then up here, we do not have any of that stuff up there, okay? So most of that we can do as far as assuming is basically all the stuff we learned in section 1.1 and 1.2 on that one, okay? So with that being said, let's go down here and let's look at these things and see if they are true or not. Okay, KHL, KHL, okay, is complementary to GHM. GHM. So we want to know this one here. So here's an interesting thing here. Complementary again means that they have to together equal 90 degrees. Do they have to be adjacent to each other? No. Are these two adjacent to each other? No. But we do know that that's 90 degrees. Is that correct? So we can write here this one's 90 degrees. We know because this one's 90 degrees, we can also say that that one is also 90 degrees for these two angles. Okay? With that being said, we can look at here. Can we say that? Maybe we can't. I'm looking at that again. I'm going to turn it a little bit more so I can look at it. Can we say that it's 90 degrees? No, we can't. So never mind on that. Okay? See, I get a little carried away and I get going too fast. So we cannot say that these are 90 degrees. We can say that the total of those are not 90 degrees, but we can sit there and look at it. Okay? Now, with that being said, here we go. Is what can we do is find out if it's a complementary to each other.